Hi, and welcome. In this tutorial, we'll build TensorSharp from source, download Gemma 4, and run it locally. I'll walk through Windows, Linux, and Apple Silicon Mac, one step at a time. Here's the plan. First, we'll check the tools on your computer. Then we'll clone TensorSharp and build it. After that, we'll download the model, try a command line prompt, and open the browser chat. One detail is easy to miss. TensorSharp includes native code for its faster backends, so we'll build the project before we run it. The first build restores the .NET packages, prepares the native backend, and creates both the command line app and the server. Later builds are usually much quicker. Before you begin, choose the backend that matches your computer. On Windows or Linux with an NVIDIA card, use ggml-CUDA. On an Apple Silicon Mac, use ggml-metal. If you don't have the native build tools, there's also a managed CPU option, but it will be slower. Let's start with Windows and an NVIDIA graphics card. You'll need Git, the .NET 10 SDK, CMake 3.20 or newer, the Visual Studio C++ build tools, a current NVIDIA driver, and the CUDA 12 toolkit. Make sure you also have at least 10 GB of free space. Open PowerShell and run the 4 checks shown here. .NET should report version 10. CMake should be at least 3.20, and NVCC should report CUDA 12. If one of these commands isn't found, install that tool, then open a fresh PowerShell window. Now clone the TensorSharp repository, move into the new folder, and create a models directory. Cloning simply gives you a local working copy of the source code, so you only need to do this once. Next, enable CUDA for this PowerShell session and build the solution in release mode. This is the step that compiles TensorSharp and its native CUDA backend. The first build can take a while, so don't worry if it pauses while dependencies are being prepared. When it finishes, you should see build succeeded. With TensorSharp built, download the Gemma 4 E4B instruction model. This is the Q80 file, and it's about 7.5 GB. Leave PowerShell open until curl finishes, and make sure the file is saved inside the models folder. Create a small text file for your first prompt, then run the command line project with no build because we've already compiled it. The model option points to the gguf file, input selects the prompt, max tokens limits the reply, and the backend is ggml-CUDA. For a more familiar chat experience, start TensorSharp server with the command on screen. Keep this PowerShell window open. Once the server is ready, open localhost, port 5000/index.html. Your conversation is now running through the model on this computer. Now let's do the same setup on Linux with an NVIDIA card. You'll need Git, curl, .NET 10, CMake, a C++ compiler, the NVIDIA driver, and the CUDA 12 toolkit. The exact package names depend on your Linux distribution. Open a terminal and check the version shown here. .NET should begin with 10, CMake should be 3.20 or newer, and NVCC should show CUDA 12. Install anything that's missing before moving on. Clone TensorSharp, enter the project folder, and export the CUDA build setting. Then build the full solution in release mode. That export remains active in this terminal, and the first build compiles the native ggml-CUDA bridge. Create the models folder and download the same Gemma 4 file. The Create Directories option makes the folder if it doesn't exist. This is a large download, so let it finish before running the model. Create the prompt file, then start the command line app with no build, because the build is already complete. TensorSharp can go straight to loading the model and generating the answer. To use the browser interface on Linux, start TensorSharp server from the same terminal environment. Leave it running, then open the localhost address shown on screen. If you use a new terminal, export the CUDA build setting there as well. Finally, let's set up an Apple Silicon Mac. You'll need Git, curl, .NET 10, CMake 3.20 or newer, and the Xcode command line tools. For this quick start, we'll use the ggml-metal backend. Open terminal and check Git, .NET, and CMake. The Xcode select command confirms that Apple's command line tools are installed. If it doesn't return a path, run the install command shown in the note and complete the Apple installer. Clone TensorSharp, enter the folder, and build the solution in release mode. On Apple Silicon, the native ggml build selects metal. We're skipping the separate optional MLX component because metal is all we need for this tutorial. Create the models folder and download Gemma 4 with curl. The command looks almost identical to Linux because both environments use /paths and a bash-compatible shell. Create your prompt file, then run the command line application with a ggml Metal backend. The no build option uses the release build you just created, while Metal runs the model on the Apple Silicon GPU and unified memory. For browser chat on the Mac, start TensorSharp server with the Metal backend. Keep terminal open and visit the same localhost address in your browser. The web interface and the local API both use the server. A quick note about no build. It tells .NET to start the application without compiling it again. That's useful here because it keeps build errors separate from model loading errors. Whenever you change the source code, build the solution again before using no build. If you can't install CMake or a GPU toolchain, you can still test TensorSharp with the managed CPU backend. The command skips both native builds and selects CPU. It works on all three platforms, but a model this size can be quite slow without GPU acceleration. If the build fails, start with the basics. Make sure the terminal is inside the TensorSharp folder and confirm that .NET and CMake are installed. On Windows, check the Visual Studio C++ workload. For Q to errors, verify the NVIDIA driver, the toolkit, and NVCC. On Mac, verify the Xcode command line tools. If TensorSharp can't find the model, check the file name in your current folder. If the download is far smaller than 8 billion bytes, download it again. For an out-of-memory error, close other applications or choose the smaller Q4KM model. Also remember that the first model load is usually the slowest. That's the complete workflow. You now know how to clone TensorSharp, build the release solution, download Gemma 4, and run both the command line app and the web interface on Windows, Linux, or an Apple Silicon Mac. For updated prerequisites, supported models, and advanced options, visit the TensorSharp repository on GitHub. Thanks for watching, and enjoy running Gemma 4 locally.